All right, here we go. Question number 8 from our Precalculus homework number 1 in MyLab Math. It says for the given functions f and g, complete parts a through h. We've got a lot of parts to do. The first thing they want us to find is f plus g of x. Over here I've written that f plus g of x is the same as f of x plus g of x. So the first step is going to be to replace f of x with what it's equal to, which is 3x plus 4, and then the sign is plus, and then we're going to replace g of x with what it's equal to. And then we're simply going to add like terms. To add f and g, you simply CLT. You're going to combine like terms. 5 and 3 is 8x. 4 minus 3 is 1, and we're done. Let's see if we're right. F plus g of x, 8x plus 1. Excellent. Next part. It says, what is the domain of f plus g? The domain in set notation, this with the braces here, these fancy parentheses are called braces. That indicates set notation. If the domain was restricted, like if the domain was not all real numbers, then you would need to put the restriction here. But in our case, the domain is all real numbers because f and g are polynomial functions. And the next step, they want us to find f minus g of x. F minus g of x is the same as f of x minus g of x. So here our first step again is going to be to replace f of x with what it's equal to. And then we're going to put g of x in parentheses so that we remember to distribute the minus sign. So here we have f of x minus g of x. The minus needs to distribute. And then once I clear the parentheses, I can combine like terms. Notice the negative changes the signs. And then we see LT. 3 minus 5 is negative 2x. 4 plus 3 is 7. And we're done with f minus g. Let's see if it's correct. Negative 2x plus 7. And then again, the next part says to find the domain of f minus g. Again, the domain is going to be all real numbers. Since f and g are polynomials, the domain will not have any restrictions. Next, we need to find f times g of x. F times g of x will be the same as f of x times g of x. Again, the first step is to replace f of x with what it's equal to. And this time we are going to put both f and g in parentheses to indicate multiplication. Now this is a binomial times a binomial. That indicates the 4-letter F word. Yes, we're going to FOIL. Here we go. First, 3 times 5, 15. X times x is x squared. On the outside, negative 9x. On the inside, plus 20x. Last but not least, minus 12. And then once you FOIL it, you got to finish it off and combine like terms. So we've got a 15x squared, 9x from 20x. 20 minus 9 is 11x, and the minus 12 comes down, and we're done. And now let's see if we're right. 15x. How do I do a squared? Well, there is a toolbar button for squared. Don't forget to move out of the exponent when you put the plus 11x, minus 12, and the domain again is going to be all real numbers because f and g again are polynomial functions. And last but not least, looks like we're going to do f divided by g, which we're going to input that as a fraction, f on top, 3x plus 4, in the bottom, g of x, 5x minus 3. This is not going to require any simplification since the fraction will not reduce, and there's no need to do long division here. Now, the domain is not going to be all real numbers this time. So I've written our answer for f over g, f divided by g of x, over here on the right. The reason that this function, this f over g of x, is not going to have all real numbers as the domain, that's because this is a rational function. Remember, rational means fractional, and rational functions have a restriction that the denominator cannot be 0. So there is going to be one value of x that x cannot be. Moving the 3 over, we're going to get 5x cannot be 3. Divide both sides by 5. Here we can see that x cannot be 3/5 because that would make the denominator 0, which would give us an undefined situation. So we are going to have to restrict the domain. We're going to choose option A. And here we're going to say the domain is the set of all x's such that x cannot be 3/5. So for part E, here they want us to find f plus g of 4. So this is going to require that we evaluate f plus g of x. Now there's two ways to do that. If we scroll back up to where we got our outcome for f plus g, that was 8x plus 1. Since we have this calculated, we can simply replace x with 4, and that will give us our answer. 4 times 8 is 32, plus 1 is 33. So we would expect the answer to be 33 here. The other way to do this, provided that you have not already done f plus g of x, is to remember that f plus g of 4 would be the same as f of 4 plus g of 4. And that says you can evaluate each function separately, plugging in a 4 for x, and then you can do the addition. You can add the results. So 3 times 4 plus 4 plus 5 times 4 minus 3 is going to give us 12 plus 4 plus 20 minus 3. 12 and 4 is 16. 16 and 20 is 36. Minus 3 is 33. Notice that that is the same outcome as if we plugged in the 4 into our f plus g of x. Okay, so there I provided you a couple of ways to get that particular answer, whether you have calculated f plus g of x already or not. And then part F, f minus g of 2. I'm not going to demonstrate both ways this time. What I'm going to do is take the shortcut, which is to go up where we have f minus g of x, and I'm going to replace x with 2. So that's going to be negative 2 times 2 is negative 4. Negative 4 plus 7 is 3. F times g of 3. Again, taking the shortcut. Here we have our outcome for f times g of x. And we're going to replace each x with 3. So here, if I use my fancy tablet, replace each x with 3. This is a fantastic opportunity to make use of our Casio Class Whiz. So this is a long expression. I wouldn't necessarily want to do this by hand, so I'm going to use the calculator. And with the Class Whiz, we can simply input that exactly the way it looks, all at one time, and it's going to give us the outcome. 156. Let's see if that is correct. Bam. All right, here we go. One more time. F divided by G of 1. Here we've got our F divided by G of X. We're going to replace each X with 1. And that would give us 3 plus 4, which is 7. 5 minus 3 is 2. That is too easy. As a fraction, 7 over 2. And that's going to do it for this particular problem. If you have any questions or comments about anything that I've covered in this problem, please feel free to leave that in the comment section below, or you can text me. And thanks for watching.